mu dv by dz. Fourier's law q is equal to minus k dt by dz. And fixed law ja is equal to the mass flux. This is the momentum flux, or you call it as the shear stress mode, or the true name is momentum flux, shear stress, or you call it as a momentum flux. And 1 minute, sir, சொல்லுங்க
சார். மார்ச் மாசம்
சார் நான் ஒரு half an hourல பேசிட்டா ஆன்லைன் கிளாஸ்ல இருக்கேன். நான் 10:45 பேசுறேன் சார். ஓகே, தேங்க்யூ. Okay, momentum flux or shear stress. This is heat flux, and this is what you call it as a mass flux. Okay, d is equal to minus dab dc by du. So general formula எழுதும்போது இந்த மூணுத்தையும் கம்பைன் பண்ணி நான் ஜெனரல் ஃபார்ம்ல எழுதும்போது what is it I can write? I can write flux is nothing but some constant, that is diffusivity of a quantity, some constant of a quantity, right, into the gradient. இது பேர் என்னது? concentration gradient. Our concentration gradient na concentration of a quantity, change in concentration for a small change in the distance, z direction, in a direction normal to the direction of heat flow. Heat transfer li நம்ம சொல்லுவோம்ல, area, the heat transfer area is the area normal to the direction of heat flow, right? So general form la எழுதும்போது what is it? I can write flux of a particular quantity is equal to some constant of proportionality, say diffusivity or thermal conductivity or viscosity, some constant of proportionality multiplied by you call it as a concentration gradient. Concentration gradient nale enna artham? It's a dc by dz, change in concentration of that particular quantity for a small distance dz, right? So in the form புரிஞ்சிருக்கும் உங்களுக்கு. So this is general form. So இப்போ momentum transfer எடுத்துப்போம், ரைட்டா? So what is the quantity we'll see? What is momentum? Momentum is nothing but product of mass into velocity. So what is flux? Flux is nothing but rate per unit area. Rate of what? Rate of change of momentum per unit area. Heat flux na rate of change of heat energy per unit area. அதே மாதிரி இது வந்து rate of change of momentum per unit area. So rate of change of momentum எப்படி எழுதலாம்? d by dt of m into v. What is momentum? Product of mass into velocity divided by area. And we know that force is tau is equal to force by area. So இது அப்படி ஞாபகம் வச்சுக்கோங்க. So இப்போ what is concentration? இங்க change in concentration of a quantity, இல்ல concentration gradient ன்னு சொல்றோம்ல. So what is concentration? It's nothing but a quantity per unit volume. அதான concentration. Mass concentration, molar concentration, நிறைய பார்த்திருக்கோம் நம்ம. Mass concentration kg per meter, kg of the solute in a meter cube of a solution. Molar concentration moles of the solute in a meter cube of a concentration, in a meter cube of a solution. So quantity per volume. So இதுல என்ன quantity momentum transferல? Momentum is the quantity. Momentum concentration of momentum from one layer to the other layer. Transfer of momentum from a higher momentum layer to a lower momentum layer, right? So momentum concentration. So quantity here is what? Momentum. So m into v is momentum per unit volume. So that is capital V. So the mass நீங்க density into volume ஆயிடுக்கங்க. So density into volume into velocity divided by v. v cancel ஆயிடும். So அப்போ momentum concentration என்ன வரும்? Rho into velocity. கரெக்டா? So நம்ம இதுக்குள்ள இருக்கிற term இப்போ concentration of a quantity ல, change in concentration of a quantity ல momentum transferல என்ன வருது? Rho into v. Okay. Rho into v divided by dz. Okay. So திருப்பி சொல்றேன். Concentration is quantity per unit volume, or momentum concentration is m into v by capital V, or Mass is nothing but density into volume. Okay. So momentum concentration is m into v by total volume. Mass is nothing but density into volume into v. So இது புரிஞ்சது உங்களுக்கு rho into v. Right. இப்போ நியூட்டன்ஸ் லா எழுதுங்க. tau is equal to minus mu dv by dz தான் நம்ம எழுதியிருக்கோம். ரைட்டா? அதை ஸ்லைட்டா மாடிஃபை பண்றேன். I'll multiply and divide by rho. So அப்போ mu by rho into d rho v by dou z. ரைட்டா? So the d rho v தான் அர்த்தம். d rho v by dou z னா இப்பதான் நான் சொன்னேன், we call it as momentum concentration. So what is it we got? We got this is nothing but gradient of momentum concentration. This term is called as gradient of momentum concentration. இந்த term பாருங்க, இது நம்மளுக்கு familiar ஆன term. Mu by rho is what? Mu by rho is nothing but kinematic viscosity. Right? So I'm able to write Newton's law as tau. Tau na the momentum flux. Flux is equal to a constant of proportionality or a constant related to that particular phenomena. Here momentum transfer la enna constant? Kinematic viscosity or momentum diffusivity multiplied by the concentration gradient. Right? Idan concentration gradient. Gradient of momentum concentration. Idla concentration gradient enna varum? Momentum concentration. That is your transfer of momentum from a higher momentum layer to a lower momentum layer. So another higher rendu fluid layers collide ஆகும்போது that's a rate of exchange of momentum happening from a higher momentum layer to a lower momentum layer. So it's a gradient of momentum concentration. Right? Right. So in the momentum transfer பொறுத்த வரைக்கும் இதான் அந்த Newton's law of viscosity. I can rewrite it as tau. Tau தான் shear stress or you call it as momentum flux. Right? Momentum flux is equal to kinematic viscosity or momentum diffusivity multiplied by d rho v by dou z. It's nothing but a concentration gradient. Right? இப்போ now let us come to heat transfer. Heat transferல நம்மளுக்கு என்ன தெரிஞ்சது? diffusion, laminar flow மாதிரி இல்ல conduction. So heat transferல என்ன வரும்? Flux of heat flux Q is equal to what is heat flux? Rate per area. Fluxனால என்னது? Rate by area. இதுல என்ன rate of heat energy, rate of transfer of heat energy by area. So இதுல concentration என்னது? Concentration is nothing but quantity by volume. What is the quantity here? Heat constant. Adula momentum concentration mari illa heat concentration per unit volume. So heat concentration you can write it as, or heat energy, concentration of heat energy from one layer to the other layer. Right? It's a gradient of heat energy. So heat nale mcp delta t. So mcp t is the quantity per unit volume by V. And M is what? M is nothing but density into volume into CPT by V. So V cancel ஆயிடும். அப்ப என்ன இருக்கு? Rho CPT. So what is the quantity here? Rho CPT. அதுல what was the quantity in momentum transfer? Rho into V. Momentum. Right? இதுல heat energy. So and you write Fourier's law. Fourier's law, flux is equal to Q is equal to minus K dt by dz. I'll multiply and divide by rho Cp. I'll multiply and divide by rho Cp பண்ணனா K by rho Cp into d rho Cp t by dz வருது. So K by rho Cp உங்களுக்கு தெரியும் என்னது? Thermal diffusivity. We have already studied this. It's a very important term. K by rho Cp is nothing but thermal diffusivity. இது என்ன வருது? முன்னாடி T இருந்ததை நம்ம multiply and divide by rho Cp பண்ணோம். This already we have explained. What is this? This is nothing but concentration of heat energy. Heat energy தான் நம்ம இப்போ rho Cp T ன்னு எழுதுறோம். Right? So the rho CP2. So now Newton's law tau is equal to minus mu kinematic viscosity into d rho v by dou z. அதே மாதிரி Fourier's law என்ன ஆயிடுது? Heat flux Q is equal to minus alpha into d of rho CPT by dz. Minus alpha into d of rho CPT by dz. So இப்படி ஆயிடுது. So என்ன இதுல ஒன்னு flux is equal to diffusivity of a quantity. Other constant of proportionality for heat transfer is nothing but thermal diffusivity multiplied by the concentration gradient. இதுல எது concentration? Heat energy as the concentration. அதுல momentum as the concentration. இதுல heat energy. So இது பேர் gradient of heat concentration. Right. அடுத்து mass transfer it's straightforward. Flux J is equal to minus DAB dCA by dz. dCA is what? It's nothing but concentration of a particular species, higher concentration to lower concentration. So flux is equal to minus diffusivity into d by dz of concentration of a quantity. Right? So in general, what is it you can write? What is flux? Flux is nothing but quantity per unit time per unit area. Correct? What is flux? Quantity. The quantity can be either, it can be a mass quantity, momentum quantity or heat quantity. Momentum transfer la enna quantity? Rho into V. Heat transfer la enna quantity? Rho CPT. And mass transfer la enna quantity? CA. The concentration of a particular species, CA. Right? So what is flux? Flux is nothing but quantity per unit time. Actually, okay. Quantity per 1 minute. Not coming. It's not coming. Yeah. Quantity okay, anyway, we'll continue. Okay, quantity, mass, momentum and heat per unit time per unit area is equal to minus diffusivity into concentration of a quantity. Concentration another quantity per unit volume. So ரெண்டு சைடும் concentration, ரெண்டு சைடும் quantity வந்து cancel ஆயிடும். இதுல ஒரு quantity இருக்கு, fluxல வர quantity, இது concentrationல வர quantity. So இப்ப மீதி என்ன இருக்கு? இந்த volume and length நான் இங்க கொண்டு போயிடுறேன். So volume into length by A into T is equal to diffusivity. Volume ஓட unit meter cube, இது meter square per second. So இந்த constant of proportionality ஓட unit என்ன வரும்? Meter square per second. Meter square per second. Thus, in momentum diffusivity la mu by rho, that is nothing but kinematic viscosity. Thermal diffusivity la K by rho Cp and mass diffusivity la DAB. All will have similar units of meter square per second. The dimensions la எழுதணும்னா L square by T. Right? ஒரு drastic similarity. Momentum diffusivity Newton's law நான் modify பண்ணி என்ன பண்றேன்? Rho வால multiply and divide பண்றேன், அவ்வளவுதான். So mu by rho becomes mu kinematic viscosity and உள்ள வந்து dv by la d m into d rho into v வரும். Right? That rho into v is nothing but the momentum concentration. Right? So rho into v. So அதுதான் momentum concentration. Right? So அதே மாதிரி heat transferல Fourier's law minus k dt by dz I multiply and divide by rho Cp. So k by rho Cp is nothing but alpha thermal diffusivity and d of rho CPT is nothing but your heat concentration, right? So rho CPT is nothing but gradient of heat concentration. And this one in the rho CPT எப்படி வந்தது பாருங்க. அது வந்து quantity is nothing but mCp delta T by V per unit volume. M வந்து rho into V ன்னு எழுதுறேன். Density into volume. So V cancel ஆயிடும். Rho CPT. Right? Okay. So now if you divide one quantity by another quantity. So நான் என்ன நான் momentum transferல I have kinematic viscosity. Heat transferல thermal diffusivity and mass transferல mass diffusivity. Okay. So kinematic viscosity by thermal diffusivity, that is mu by alpha is equal to kinematic viscosity is mu by rho divided by alpha is K by rho Cp. Okay. So mu by alpha is nothing but kinematic viscosity by thermal diffusivity is nothing but mu by rho divided by K by rho Cp. So அதை rearrange பண்ணி எழுதினா என்ன ஆயிரும்? Cp mu by K. Cp mu by K is what? Prandtl number. So Prandtl number is what? Momentum diffusivity by thermal diffusivity. ஒன்றும் இல்லை, அந்த terms நம்ம you divide one by the other, you get a dimensionless number. அதே மாதிரி பாருங்க, I am dividing kinematic viscosity by diffusivity. Mass transferல வர diffusivity-ய heat transferல இருக்கிற kinematic viscosity, momentum transferல இருக்கிற kinematic viscosity-யோட divide பண்றேன். என்ன வருது? mu by dAB or I'll mu by rho அதாவது multiply and divide by rho. So அப்ப என்ன வரும்? mu by rho is nothing but kinematic viscosity divided by what is it? You call it as mass diffusivity, right? So mu by the kinematic viscosity divided by mass diffusivity, that is nothing but Schmidt number, right? That is nothing but Schmidt number. எப்படி வந்து Prandtl number heat transferல வருதோ, similar to Prandtl number in mass transfer you will get Schmidt number. It's nothing but mu by rho dAB. அதுல Cp mu by K, right? அடுத்து பாருங்க, I'm dividing heat transfer term, that is thermal diffusivity divided by mass diffusivity, and I multiply and divide by alpha is nothing but K by rho Cp by 1 by dAB. So it's nothing but K by rho Cp dAB. You get another number called, another dimensionless number called Lewis number. Lewis number is nothing but the ratio of thermal diffusivity divided by mass diffusivity. Right? This is also equal to Schmidt number divided by PR by Prandtl number. Okay. So நம்ம என்ன ட்ரை பண்றோம்? We are just trying to find out general relation between momentum, heat and mass. We considered for laminar flow, conduction, diffusion. We wrote down the basic laws and we are trying to fit it into a general form. What is the general form? Flux is equal to the constant of proportionality into driving force, or the concentration gradient. Concentration gradient is nothing but a concentration of a quantity, change in concentration of a quantity for a small distance, dz, in a direction normal to the flow. So momentum transfer la we are able to write it in terms of like this: flux tau is equal to minus mu d by dz of rho into v. Rho into v is nothing but momentum concentration, gradient of momentum concentration. Heat transfer la we are able to write it as Q is equal to minus alpha into d by dz of rho Cpt, and mass transfer la we are able to write it as flux is equal to diffusivity into change in concentration of a quantity by dz. So flux எப்படி எழுதலாம்? quantity of a particular substance per unit time per unit area into constant of proportionality into concentration of a quantity another quantity per unit volume, right? So quantity cancel ஆயிட்டு diffusivity the constant of proportionality unit வந்து meter square per second வருது, right? So if you divide one by the other, so I'll get different dimensionless group. One is what you call it as a Prandtl number, Schmidt number, Levi's number, and so on, right? Okay. So now, why we are interested in analogy? For example, we want to know the value of K in turbulent flow, mass transfer coefficient and theriyano, turbulent flow conditions. But a lot of work has been the same setup, right? For the same fluid, a lot of work has been done with respect to heat transfer evaluation. So now I have developed a relation between mass transfer and heat transfer. Suppose if you are able to derive an expression for H, then if I am able to convert H into K calculate பண்ற மாதிரி ஒரு provision இருந்தா, it will be very useful to me. You know, generally heat transfer measurements are easier compared to mass transfer. Mass transfer concentration measure பண்றது கஷ்டம். There is no meter called concentration meter. Heat transfer நீ temperature easier measure பண்ணலாம், right? Thermometer or any sensor. But concentration ko direct measurement கிடையாது. You have to go only for indirect measurement, right? There's nothing called concentration meter which will suppose I am drinking orange juice. If I dip a meter, if it indicates the concentration of the orange in the juice, there's no such meter. அப்படி இருந்தா நம்மளுக்கு எல்லாமே ஈஸியா இருக்கும்ல. நம்ம எவ்வளோ அடல்ட்ரேஷன் பண்றாங்க, எவ்வளோ வாட்டர் இருக்கு, எவ்வளோ இது இருக்கு, எல்லாம் ஈஸியா கண்டுபிடிச்சிடலாம். அந்த மாதிரி ஒரு மீட்டர் கிடையாது. we have to indirectly measure it. இப்போ மில்க்ல தண்ணி நிறைய கலந்ததுன்னா there is something called lactometer or hydrometer ன்னு ஒன்று இருக்கு. ஸோ இட் வில் அது இன்டைரக்ட் மெஷர்மெண்ட் தான், டைரக்ட் மெஷர்மெண்ட் கிடையாது, ரைட்? ஸோ அனாலஜி எதுக்கு படிக்கிறோம்? நம்ம ஒரு ஃபீல்டுல இருக்கிற பேராமீட்டர் வச்சு இன்னொரு ஃபீல்டுல இருக்கிற அதர் சிமிலர் பேராமீட்டரை we can easily evaluate. So knowing the values of heat transfer coefficient, I can evaluate mass transfer coefficient. That's the idea. So this idea of analogy was started by Reynolds analogy. He brought an analogy between momentum and heat. So he is the first one. But என்னன்னா Reynolds analogy is very good, but he took a fluid and he said that the fluid is both momentum transfer and heat transfer is happening between the layers of fluid. Momentum transfer எப்போ ஆகும்? When one fluid has a higher momentum compared to the layer above it. So there is a transfer. These two fluids shears against each other. There is a transfer of momentum from one fluid to the other fluid. Heat transfer எப்போ வரும்? When one fluid is at a higher temperature compared to the other fluid. So because of the difference in temperature, there will be transfer of heat energy. அதான் momentum concentration பார்த்தோம், rho into V. Heat energy concentration, rho CPT, right? அதான் heat energy concentration. That's a gradient. Okay, there will be a flow in the direction normal to the flow. Flow இப்படி ஆகுதுன்னா இந்த directionல momentum transfer ஆகும், heatum transfer ஆகும். So he said that the transport mechanisms of both momentum and heat are same. So he thought that okay, if the transport mechanisms are same, then I can introduce a general transfer coefficient, heat transfer coefficient, friction factor, mass transfer coefficient எல்லாம் இல்லாம நான் general transfer coefficient ஒன்று introduce பண்ணலாம் அப்படின்ட்டு he introduced a term called eta, just like H or K or F, right? F friction factor அதுவும் நீங்க எக்ஸ்பெரிமெண்டலா டிட்டர்மைன் பண்ணணும். H heat transfer coefficient அதுவும் எக்ஸ்பெரிமெண்டலா தான். K mass transfer coefficient. Only for laminar flows you can derive some equations. F is equal to 16 by NRE derive பண்ணலாம். I mean H is equal to say for the 1 minute here. getting used to this. Okay. So generalized transfer coefficient is nothing but eta. So every flux is equal to some constant into driving force. So that constant eta is nothing but flux divided by the change in the concentration. Right. So now the mass transfer coefficient, heat transfer coefficient, friction factor I'm trying to relate it with a common term, general term eta nu solra. Adu oru coefficient. Generalized transfer coefficient. So generalized transfer coefficient eta is nothing but flux divided by change in the concentration. Concentration another. So momentum transfer la momentum concentration rho into V. Heat transfer la rho CPT. I mean mass transfer la CA, concentration of a particular species. So this will have identical units for momentum, heat and mass. So eta is what? Flux divided by change in concentration. What is flux? Quantity of a substance per unit time per unit area. Okay, flux marandradinga. What is flux? Quantity of a substance per unit time per unit rate per area than a flux. And what is concentration? Q by meter cube. Right? So, eta or unit enna varano? This Q by meter square second. This Q by quantity per meter cube. Now, concentration is what? One meter cube of this ஒரு வால்யூம்ல எவ்வளவு குவான்டிட்டி இருக்கு? Q by m cube. ஸோ இது பார்த்தீங்கன்னா இந்த ஈட்டாவோட இது என்ன வரும்? மீட்டர் பர் செகண்ட். ரைட்? So you just described, you say that why don't we try relating all the three transport process with a common term called eta. Right? So eta will have the unit of meter per second irrespective of what is being transferred. Mass, heat, momentum, transfer pannikko. I'll use a term called eta which will have the units of meter per second. இப்போ என்ன entity momentum அப்படின்னா what is flux, shear stress or momentum flux. அது concentration என்னது? இப்பதான் சொன்னேன், change of rho into V. அதான் momentum concentration. So அப்ப eta என்ன வரும்? Flux by change in concentration. What is flux? Tau. Tau தானே உங்களுக்கு momentum flux. Tau by delta of rho into V. So அடுத்து heat. So what is flux? Heat flux, Q. What is the change in concentration? Delta of rho CPT. Rho CPT. Adana concentration, heat energy concentration. So what is flux here? Eta H. That is eta for H, heat energy. Right? Is equal to Q by, what is flux? Q. Divided by, what is the change in concentration? Delta of rho CPT. Right? And what is mass? Mass level, the mass flux, Na. What is the change in concentration? Delta of Ca, concentration of a particular species. So what is eta for diffusion? That ED சொல்றாங்க. அது diffusional mass transfer. Is nothing but flux divided by concentration. So Na is the flux divided by delta Ca. Right? So consider momentum, heat and mass transfer taking place from I think in 1 minute it will get over. Okay, I'll just try to complete this. Okay, next class la paakalam. Right? So afternoon we'll have the class. என்ன டைம் வச்சுக்கலாம் ஜீவா? 5 o'clock okay ba?
Okay sir.
Sure, right, okay. So we'll meet at 5. Please kindly join at the earliest because இங்க 5 minutes joining time போயிடுது. ஏன்னா Zoom வந்து 40 minutes தான் எடுக்க முடியும் maximum free இதுல. Otherwise we have to pay from 1,500 or 2,000 for paid membership, right? So இந்த மாதிரி 35 minutes நம்ம எடுத்தா அதான் நம்ம இது அட்லீஸ்ட் 4 classes முடிக்க முடியும். சரியா? அதனால ஈவினிங் ப்ளீஸ் ஜாயின் பை 5 எக்ஸாக்டா 4:58க்கு ரெடியா உட்காந்துருங்க. நான் 4:59க்கு ஐ ஓப்பன் திஸ். ஸோ இமீடியட்லி வித்தின் 1 or 2 minutes யூ ப்ளீஸ் ஜாயின். ரைட்? ஸோ இந்த நோட்ஸையும் கையில் வச்சுக்கோங்க. So that it will be easy for you to refer. Okay, we'll meet in the evening 5. Okay, bye.